designed this house to, primarily we were looking at designing the house to be LEED, and our goal was to achieve LEED Platinum. But I had been interested in passive house design for some time. And passive house is an energy standard. In the 1970s, there was an energy crisis in the United States, and a number of people were invested in designing buildings that were super energy efficient. They call them super insulated homes. When the energy crisis resolved itself, that kind of fell by the wayside, but the Germans took over the technology and really took it to the next level, developed some software to refine it further, and they've managed to develop an energy standard that is quite incredible, and uses about 1/10 of the energy that we would use in a standard code-built home. And so I wanted to test the boundaries of that. But in order to achieve passive house, you have to meet these standards. There are a couple of things that it does require. The first thing is that you meet an energy use of 4.75 kBTUs, 1,000 BTUs of energy per square foot per year. And that's one aspect. The other is that you seal the house up so well that you avoid any air infiltration, like leaks around windows and doors, to a level that's identified by the number of air changes per hour, and that's held down at 6/10 of an air change per hour, which is a tiny fraction of what building code today allows. So with that in mind, we went about trying to design this house to meet that standard, and we hired an engineer that specializes in designing passive house. We had a layout in mind because our number one goal was to make this a retirement home, and we wanted to have it barrier-free. We wanted to make it a barrier-free design. And to do that, we felt that we wanted to keep everything on one floor. That is unfortunately a challenge when you want to build passive house. Passive house does best when you have the smallest floor to wall area ratio, and you don't get that with a single floor building. You get that when you have essentially a cube, a two-story cube, and that's where the floor area to wall area ratio is the smallest. And so even though we were able to take our floor plan and design it to meet passive house standards, it was very difficult to accomplish. We had extremely thick walls. They were 21 inches thick. We had 3 feet of insulation in the attic, and we had windows that only one manufacturer in the world could construct. And that was, for us, cost prohibitive. It was out of our budget. And so instead we lightened up the wall profile a little bit, which helped us with the dew point location in the wall. And we also changed the window spec, and we were able to get that in budget, and we were able to buy then a heating and cooling system. With the passive house system, we would have not needed to buy a heating system. We would have been able to essentially heat our rooms with a 500 watt bulb, probably 1,500 watts of heat with the passive house design, which you can do with a little electric room heater. would have been more than enough to heat our home at 0 degrees outside. And we opted instead, with the savings that we made, with the window selection, we could afford to buy a heating and cooling system. The selection that we made on the windows, we bought at a price point where the return on investment was about 10 years, since we plan to live here until we pass this on to the next generation. We were able to make design decisions that might be different than you would make for another house, a spec home or something like that. And the window that might have gotten us to the passive house, the payback on that was more than 45 years. And that wasn't acceptable to us. The efficiency of the window might deteriorate in that period of time. And so we felt that was not going to be a good trade-off for us. The second thing is that one of the things that we wanted to be considerate of was the potential of the resale of the house. And for a buyer to walk into a home that didn't have a furnace, that had a 500-watt bulb in a room as a heat source when it got down to 0 degrees would freak them out. And to not have any method of heating and cooling other than that, not having a furnace, we thought was something that could potentially be a deal breaker. We were able to get all of that within our budget by a window that was slightly less efficient but did not get us to the passive house level. We have the solar generation installed. We purchased 40 panels of unisolars, PVL 144 panels. Unisolar is not in business any longer, but they had a very elegant design, and was one that we had designed the roof around, not only structurally but also the standing seam metal panels. We were able to still acquire the panels, the aftermarket. We designed the amount of power based on estimates of the amount of consumption that we would have in the building. And today we have about 5 months of data on how much actual consumption we have in the building, and it's almost 750 kilowatt hours per month. Now, you may recall that we made a design decision not to use any fossil fuels at all. We wanted to use only alternative energy as a source of power for this building. And that happens to exceed our budget by almost 200 kilowatt hours. So there are a couple of reasons for this, we think. The first being, we went through the hottest summer on record, and we did quite a lot of cooling during the summer, and we also had a tremendous amount of moisture from construction. We're heavily reliant in this house on thermal mass for maintaining an even temperature. So there's a lot of concrete in the building, and then we used a wet blown insulation. And we've had 2 large dehumidifiers that we keep in the house that we have been running almost full-time until the middle of December. They've been off now for about 4 weeks. And they do gobble up an awful lot. So hopefully things will have dried out enough by next year that we'll be able to shave some of those loads off and get down a little bit closer to our budget. It's winter time now. We're going to show you some pictures here of the panels that are covered with snow now. So the days are quite a bit shorter, but on a cloudy day, we're generating about 15 to 20 kilowatt hours. On a sunny day, it's at least 40 to 50 kilowatt hours. And that's in a winter day, which is maybe 8 hours long, with the sun low on the horizon. So in the summer, we're hoping that we're going to generate probably 4 to 5 times that amount of power, which will make up for the low output levels that we're seeing right now. Of course, on a day like today, it snowed all day yesterday, so we've got a little bit on top of the panels. It's really kind of interesting. When the sun is out and there's snow on the roof, it comes up and it heats up the attic space, and about 10 o'clock in the morning, the attic space gets warm enough to heat the metal roof, and the roof begins to shed, and it makes an amazing sound as it slips off the roof, and we deliberately did not put any snow jacks at the end of the roof to prevent snow from coming off, so that we could clear the ice and snow off the panels. But it's quite a sight to see as I call it, our self-cleaning roof cleans itself off.
Good.
Mm-hmm.